Hey, so welcome back, and this is another daily LeetCode problem. So today it was called Profitable Schemes, and it's a dynamic programming problem. And so what you're given here is a bunch of inputs. The first one is just the number of members that you have, or number of people. The second one is the minimum profit that you're trying to achieve for a particular scheme. And then the second or third and fourth inputs are kind of joined together to make up a particular scheme. And so it just means that the scheme at index 0 requires 2 members, but it would make a profit of 2. And then the scheme at index 1 would require two members and would make up a profit of 3. And so all that you want to do is calculate the number of profitable schemes that you can make. Now, the thing to understand is you can only use a scheme once, and so there's 2 schemes here, scheme 0 and scheme 1. Same thing here, scheme 0, scheme 1, you use these 2 arrays to make up that scheme. And so you get an output of 2, and that's because you can only make up 2 different ways to get a profit greater than or equal to 3. And that's by using both schemes, because you have 5 members, and using both schemes that only requires 4 members. And so that checks off the list. And then it would add to 5. You would have a total profit of 5, which is also greater than or equal to the minimum profit. And so that's a valid scheme. And then the other way you can do it is that you just use scheme 1 here, which has a profit of 3. It only requires 2 members, and you have 5 members, so that you have enough. And then that 3 is greater than or equal to the minimum profit. Okay, so we're going to do a top-down dynamic programming solution for this. And so you just want to return the result of a function that we're going to create with 3 different input variables. And we're going to cache this, so it's a memoization solution. So let's define our function here. And one thing to remember is we want to return the modulus of this result. And so let's just mod a result, and we'll define that up here. Great. And so this is going to take in 3 parameters. The first one's the index, and that just represents which scheme you're looking at. So I will initially be 0 to say that you're looking at scheme at 0. And then the second is just the current profit that you have. And so you naturally want to get the current profit to be greater than or equal to the minimum profit. And then finally, you just want to track the number of members that you've used, and you want that to be less than or equal to the total number of members that you're given. Okay, and so we want to do our base case here. And so what that's going to be is, okay, if I is equal to the number of schemes that's given to us, which we can use either the group array or the profit array to give us the number of schemes. So that means, okay, we ran out of schemes, so let's kind of return and propagate upwards that result that we achieved. So we want to return 1 and include this case if we meet both conditions, and that's if our current profit is greater than or equal to the minimum profit, and the number of members that we've used is less than or equal to the number of members that we can use. And if it doesn't meet both of those cases, then we just want to return 0, because this is not a profitable scheme. Okay, and so next we have 2 cases, case 1 and case 2. The first one is we want to return, so at the end of this, some result or some answer. And that's going to be, for case 1, is we can just skip the current scheme. And so what that looks like is that, say you're looking at group or scheme 0 here at index 0, instead of saying, okay, I want to use 2 group members and make the profit of 2, we could just say, why don't we just skip it and move on to the next scheme, and let's consider that one. and that's a valid case. And so you just call this recursive function and you increment I, which points to the current scheme that we're looking at. And then we just keep the current profit and the number of members that we've used so far the same because, well, we haven't used any members to make any profit. So it's the same. Otherwise, we want to, for case 2, actually use that scheme. So use scheme at index I. And this is as long as we have enough members. So if I was 1 right now, and if we want to make use of this scheme at index I and have the profit of 3, then we need to have at least 2 members remaining. So that we just have to check if we have enough members, and that is if n, which is the total number of members that we can use, minus the number that we've used so far, then that has to be greater than or equal to the number of members that we need for the scheme at I. And so that is n minus number of views, so then that gives us how many members remaining that we have. And we expect that number to be greater than or equal to the number of members we need for scheme at I. Okay, and so then we just want to add to our response that case, and we can just do plus equals the recursive call to our depth first search function. And so we want to increment our pointer to move on to the next scheme because we just profited from this one. And then we want to increment the current profit because we just profited from scheme at I. And that is the current profit plus the profit at I. And then finally, the number of schemes or the number of members we've used so far has increased because we just used this many members in order to obtain the profit at I. And so let's increment that value. Okay, so we run that. So this passes this case, and the interesting thing about this is we'll get a like out of time or TLE error on LeetCode. And it's so weird where I don't know how they programmed it for calculating like the amount of time things take, but literally to fix this problem for this solution is all you have to do is take the profit here and take the minimum. So I don't know if it's the values that they're using and this just creates a value too large, but you just take the minimum of this and pass in the min profit. And so as long as you're passing in like the current profit, that's the minimum of the minimum profit and like the profit that we're tracking, you'll not get this error. And yeah, so that's the solution. So I think this is a good one. You can obviously do like a bottom-up solution for this, but for me, I've just been practicing doing memoization solutions. It's way more intuitive and always acceptable. Typically, it's not the best solution, but it's a good enough solution to pass on LeetCode and during an interview or like in a coding competition or whatever. So I think it's a great way to practice. And so splitting up into the base case and all the cases that you have to consider and just like adding those cases together is how you solve it. So yeah, I hope that helped and good luck with the rest of your algorithms. Thanks for watching.